So to factor a difference of cubes, we have perfect cube, perfect cubed. So our first, this is one that goes into 2 terms and then 3 terms in the other parenthesis. Some of your teachers probably called this bouncy bouncy. There's also the SOAP reminder for this. But the way it works, take the cube root of each of those. So cube root of 64, that's 4 times 4 times 4, so it's 4x. The cube root of 125 is 5, and then y. Then it's, you square the first term, so 4x times 4x is 16x squared. Then you multiply the 2 terms together, so 5 times 4 is 20. X times y is xy. And then you square the back. Squared, multiplied, squared. So 5y is 25y squared. And then comes SOAP. Tells you about the signs. It's the same sign. It's the opposite sign. And AP is always positive. That last one's always positive. And that's factored. Find the domain of the composite function f of g. So since it starts with g, you have to look at the domain of g. And in that, x is not allowed to equal -4 because then you'd be dividing by 0. And then you look at the composite, where you plug g into f. So g gets plugged in to f. So that'd be 4 over x plus 4 plus 9. Then when you're doing the domain of the composite, once you do the composite, you look at what you're not allowed to do in f of g. Still, the 9 doesn't affect anything. So the only thing that matters here is you still cannot divide by 0. So x is still not allowed to equal -4. And since it's a composite, you have to look at both pieces. In this case, they were the same, though. X can't equal -4, and x can't equal -4. Everything else is okay except for -4. So the domain is everything except x equals -4. If you write that as an interval, that's -∞ to -4 with a parenthesis because it cannot equal it. Union -4 to +∞. Everything except -4. If those were 2 different values, then we'd have to probably exclude 2 different things because both the domain of G and the domain of the composition both have to be included. For the transformations, a +1 on the x is going to shift it left to right. So +1 is actually a shift left 1. And this negative in front, it's not on the x, which means it reflects over the x. This 2 just does a stretch the -5 that's there with the x, that is a shift. And it's 5 to the right. The 2 is a vertical stretch. Now we have a negative on the x, which reflects, since it's on the x, it reflects over the y-axis. And then the minus 3 at the back, that is not with the x, which means it's vertical. So it is a shift, a vertical shift in the negative direction, so that's down 3. The key to these quadratic inequalities, whenever you have a x squared and a greater than or less than, you need to get the picture of the graph. So from the graph, you need to know which direction is the parabola opening. In this case, it's negative x squared, so it opens down. And you need the critical numbers, which are the roots. So we need to find the roots. To do that, you're basically just solving the equation if it was an equals instead of a greater than. So negative x squared plus 2x plus 15. Pretend it's equal to 0 to get the roots. If it's a calculator question, you just type it in and do gsolve root. And then to solve this, I would change that to positive x squared, so change all the signs. Then it's factorable. Negative 5 times positive 3 would be negative 15, and negative 5 plus 3 is negative 2. So we have x equals 5 and x equals negative 3, which means when it crosses the x-axis, this is negative 3, and this is positive 5. That's all we need to know. We just need to look now at the greater than or equal to. Greater than or equal to means above the x-axis. It is above the x-axis between negative 3 and 5. From negative 3 to 5, that's where it's above the x-axis. And then equal to means that we put brackets for our interval. So when you have a piecewise function and you're just plugging in, we're plugging in negative 2. You have to determine which piece it gets plugged into. So since negative 2 is less than 1, it's not greater than 1, it's less than 1, we're plugging into the top equation. The bottom equation has nothing to do with this problem. So negative 2 gets plugged into 2x squared plus 7. That's 2 times 4 plus 7 is 15. See which piece it gets plugged into, then plug it in and get your answer. You're investing money in a savings account. 12 years later, it's $5,726. Interest is compounded quarterly. What is the interest rate? So for these, I always start by writing down A, P, R, N, and T. A is the amount you have at the end of the loan. So 5,726. T is the principal or the starting amount, which is 4,000. R is the interest rate. That's the question mark. That's what we're solving for. N is how many times it is compounded in a year. So since it's quarterly, that's 4 times per year. And T is how many years, which is 12. Then you plug it into the formula. A equals P 1 plus r over n to the nt. Plug in everything that you know. We don't know r, so leave it as r. N is 4. 4 times 12 for the exponent is 48. So when you're solving, you first need to get the parentheses by themselves. So we'll do that by dividing by 4,000. Then we will get rid of the exponent by doing since it's a 48 as an exponent, you would do 48 as a root. That's the index of our root, of our radical. So you type that into your calculator, you get 1.0075 equals 1 plus r over 4. So to finish that off, you would subtract the 1. So you just get 0.0075 and then multiply by 4 to find r. And you get 0.03000555. And that is our interest rate, which should be written as a percentage. So move it 2 spaces for your percent, and you get 3.000%, so 3%.